Let's look at the test you're understanding to see how well you did. First thing I do is I do the ruler test. Are these straight lines? Yes, they intersect each other, and M and 43 are vertically opposite. So M equals 143. M equals 143 degrees. Reason, vert, op, angles. Let's have a look at number 2. The first thing I look at, I see there are a whole lot of angles, but they share the same vertex. So these are angles round a point. So the statement, I need to do a plus statement to describe the diagram. So I'm going to say 108, so 108 degrees plus 36 degrees plus 2p plus 4p equals 360 degrees. Reasons, angles, round a point. Right, I'm going to gather like terms. So I'm going to add 108 and 36. So 108 and 36 will give me 144 degrees. Plus, these are like terms, 2p plus 4p will give me 6p equals 360 degrees. I'm calculating, so I do not need a reason. So 6p, I'm going to minus 144 degrees from both sides. 6p will equal 360 degrees minus 144 degrees. So if you take out your calculator or you do that, 360 minus 144 will give me 216 degrees. I want p on its own, so I divide both sides by 6. So p equals 36 degrees. Let's look at the next one. Again, I have a straight line. This is my straight line. And I cannot do angles round a point because I have a G and I have two F's. So I cannot work with two variables in the same equation at this point in time. So I'm going to have a look at my straight line and I'm going to describe that. So F plus 120 degrees equals 180 degrees. How do I know that? Well, they are adjacent angles on a straight line. So now we'll say F equals 180 degrees minus 120 each side, minus 120 degrees. So 180 minus 120 degrees. So F equals 60 degrees. It's sometimes a good idea to go and fill in your variables on your diagram. So that would be 60 degrees. And if F is on the same diagram, it means wherever you see an F, those are 60 degrees. Right, I'm now going to look at my angles on the bottom of the straight line. So in other words, I'm looking at these three angles. They share a common vertex. So I do, in fact, have adjacent angles on a straight line. I must describe my diagram. So F plus 90 degrees. This symbol is 90 degrees. Plus G equals 180 degrees. A G angles on straight line. Right, now I'm going to solve. F was 60, so I can go 60 degrees plus 90 degrees plus G equals 180 degrees. 60 and 90 is 150, so 150 degrees plus G equals 180 degrees. I'm going to subtract 150 from both sides, balance my equation to get G on its own. So G equals 180 degrees minus 150 degrees. So G equals 30 degrees. And now you've solved for all the variables. Let's look at the last one. Again, we go and highlight the straight line. So we have two straight lines. X is vertically opposite to 25. So I can immediately say X equals 25 degrees. vert op angles. Now I can say that x plus z equals 180 degrees because those are adjacent angles on a straight line. They share a common vertex. So x plus z equals 180 degrees. Adjacent angles on straight line. I now go and fill in. So 25 plus z equals 180 degrees. I want z on its own, so I'm going to minus 25 degrees this side, minus 25 degrees that side. So z equals 180 degrees minus 25 degrees, and that will give you a total of 155 degrees. So z equals 155 degrees. So z is 155 degrees, x is 25, and if you have a look here, you can see that this angle is vertically opposite to that angle because they are in between, or vertically opposite positions for those two intersecting lines. So let's describe the diagram. So we're going to say y plus 90 degrees, y plus 90 degrees equals 155 degrees. Why can I say that? Well, vert op angles. Please don't write vert op angles are equal. It is implied by this, and you need to write it as required. So y equals, I'm going to minus 90 here, and I'm going to minus 90 there. Y equals 155 degrees minus 90 degrees. Y equals 65 degrees. You could have also, so there are many ways to do the riders, as long as your reasons are correct. You could have done that one like this. Y plus 90 plus 25 is 180. Or you could have used this straight line. X plus y plus 90 is 180. You would still have reached the same conclusion or the same answer at the end of your rider. Now you are ready to do exercise 2.1.